So in this video, we are going to work on something that you've actually seen before a little bit, but we're going to go into it in more depth, and that is binary operation tables. So we're going to define how binary operation tables work. We're going to demonstrate that binary operation table on an example. We're going to show how to use the properties of binary operations to fill out a binary operation table where maybe not all the entries have been put in. All right, so the symbol we're going to use for our binary operation is the star symbol. And what we can do is we can make a table that shows all the ways we can compute with star by using an array. So a table, it's a rectangular table. So each row of the array represents an element of S, and each column of the array also represents an element of S. And each entry within the array is an element of S. So if the row represents X, and if the column represents Y, then the entry in the row with X and the column with Y is the element X star Y. So here is a random binary operation that I made up on the set WXYZ. And I put the star in the upper left to indicate that's what the operation is. And if I want to know, say, what X star Z is, I would find the row with X, which is the second row down. And I would find the row with Z, that is the row way to the right. And then I'd find the element that is in the same row as X and the same column as Z. That's that W right there. That's all three of those are bold-faced. And that gives us X star Z equals W. So now I'm going to look at a situation where our operation table is only partially filled out, but we are going to make an assumption on the binary operation. We are going to assume that the operation is associative. So here's our table, and it only has three operations filled out. We know that alpha star beta is equal to beta. We know that beta star beta is equal to gamma. And we know that gamma star gamma is equal to beta. So we're going to fill out some of those empty squares. So first of all, we're going to look at alpha star gamma. Now, we want to use the fact that our operation is associative. That only works if we have three elements that we're starring together. So that means, so one of the ways that we could do that is take either alpha or gamma and replace it with two things that are starred together, and that would give us three things starred together altogether. Now, alpha does not appear at all in that binary operation table, but gamma does, right? Gamma appears as beta star beta. So if I take that gamma and replace it with beta star beta, then I get alpha star beta. And now I can use the associative property. I get alpha star beta. And the nice thing is, I know what alpha star beta is, right? That alpha star beta is equal to beta. So that gives us beta star beta. And the other nice thing is I know what beta star beta is. That's equal to gamma. So that gives me gamma. And so alpha star gamma is equal to gamma. And so I can put that in my table, right? Now for beta star gamma, I'm going to use a slightly different strategy. Instead of saying, of trying to affirmatively show what it is equal to, what I'm going to do is I'm going to try to eliminate as many possibilities as possible, see if I can narrow it down to one or at least just a few. So I'm going to make a guess, and I want to guess something that I think it's not going to be, so I'm pretty sure that it's probably not going to be equal to beta. And so then what I'm going to do now is a proof by contradiction. Let's assume beta star gamma is equal to beta, see if we can see if something goes wrong. So the nice thing about having an equality to work with, an equation to work with, is that I can do the same thing to both sides of those equations. But if I'm going to star both sides by the same element, I've got to make sure and do it on the same side because I don't know if the operation is commutative or not. So if I want to star both sides by, say, gamma, right? I'm going to either have to do on both sides on the left or both sides on the right. And just, let's just try both sides on the right to see what we get. Now, the interesting thing I have here is if I see that beta star gamma on the right, if I look just to line up, by our contradiction assumption, I'm assuming that's equal to beta. And if I look at what I have on the left, that is multiplying three things together. I can use the associative property. So I'm going to dig both of those things in. I'm going to move those parentheses over so that they're surrounding gamma star gamma. And I'm going to replace beta star gamma with beta because, again, we're assuming by contradiction that beta star gamma is equal to beta. All right, so now let's see what that gives us. Well, I know what gamma star gamma is, right? I have that one. Gamma star gamma is equal to beta. And so I can replace that with beta. So I have beta star beta equals beta, except that it doesn't. If I look at the binary operation table, beta star beta is equal to gamma. So I get gamma equals beta. Those are two different elements. That is a contradiction. So no, beta star gamma cannot equal beta. One down. Let's see if we can eliminate another one. Let's see. Can beta star gamma equal gamma? Well, let's try it. Once again, I'm assuming that, so I'm going to do the same thing to both sides. And once again, I'm going to star both sides of that equation by gamma on the right. And when I do, let's see what I get. Well, again, I can use the associative property on the left side of that equation. And gamma star gamma, I can look at the table. That's just going to give me beta, right? So there it is. And so I move those parentheses over. I replace gamma star beta with, or gamma star gamma with beta. And now, once again, I know gamma star gamma is equal to beta, so I can replace that with beta. And I know beta star beta is equal to gamma. So once again, I get gamma equals beta, and that's no. So I can't have beta star gamma equal to beta. I can't have beta star gamma equal to gamma. There are only three elements in my set, and I have to have my operation be closed. So my only other possibility is that beta star gamma is equal to alpha. So that gives you an idea of some of the strategies that you can use in filling out binary operation tables. All right, so now let's see if you can apply some of these strategies in the PDF file called Addition and Multiplication Tables that's included with this video.